Hello, in today's video we're going to be talking about the three different types of equations that chemists can use to identify different aspects of a chemical reaction. So I have a balanced chemical reaction. We know how to balance them. We learned that on Monday. And we know that each reaction has to have the state of matter, all the subscripts, stoichiometric coefficients if it's a balanced equation, the yield arrow. So this is a balanced chemical equation. Now, if we start out with this type of an equation, this has a special name. This type of a reaction, this type of equation is called a molecular equation. So I'm going to say molecular equation. The reason why we call it a molecular equation is everything is in their compound or molecule form. This is written in its compound form. This is written in its compound form, compound form, compound form. Okay? So this is the first type of an equation that chemists can use in order to identify certain properties of a reaction. In this case, what the actual molecules and compounds are that are taking place in that reaction. The second one I want to talk about is the total ionic. Now, sometimes in chemistry, naming systems are kind of weird. They don't really discuss a whole lot of what's going on, but these naming systems actually tell you exactly how you're going to write the equation. So the first equation was the molecule compound notation. Second one is total ionic. What this means is we need to separate every compound into its ionic form. So anytime we see a subscript in the molecular equation that has an AQ, we're going to separate that out into its ionic form. So here, barium nitrate has an AQ in the subscript, which means it's an ionic bond and it's not going to be a solid in water. So it's going to fall apart. So we can separate these out into the ions. So we know the first ion is going to be barium and it has a 2+ on it. That's what this barium here has. You can figure out the charges on everything. We know how to do that. So this barium 2+. We also have to write the subscript here, AQ, because it's still floating around in water. So what this means is I threw barium nitrate into water. Barium ions are kind of just floating around in water. But now there are also 2 nitrate ions. Remember, covalent bonds are not going to fall apart in water, so this thing is going to stay, this polyatomic ion is going to stay as a polyatomic ion. So it's NO3-. That's also going to be aqueous, but this 2 we have to take care of. So the subscripts that are on the outside of parentheses for polyatomic ions become stoichiometric coefficients in the total ionic equation. Great, so we have 1 barium ion floating around and 2 nitrate ions floating around when we throw in 1 compound of barium nitrate. We do the same thing for all the other compounds. Na2, the 2 is part of an element. We don't have an Na2 floating around. We don't have this. That's not an ion. We actually have an Na+, that's its ionic form, and the 2 becomes a stoichiometric coefficient. So just like the subscript on the outside of parentheses becomes a stoichiometric coefficient in the total ionic equation, the subscripts on elements become stoichiometric coefficients in an ionic equation, total ionic. Q, we're going to add to that carbonate. There's no extra subscripts, so it remains a carbonate ion, 2- AQ. Now I'm going to draw the yield arrow over here because I'm going to run out of room. So this should be, this is our reactants, and over here I'm going to write the products. I've just separated the equation into 2 different lines. Barium carbonate is kind of special in this equation. It's what's known as a precipitate. This solid here means that it's going to remain solid. Even though it's an ionic bond, it's going to remain solid in water. So this thing cannot be separated. We have to write the entire compound here. BaCO3 solid. So how do we identify which ones we separate and which ones we don't separate? Okay. Anytime we have a subscript that's an AQ, you separate it. Anytime it's anything else, liquid, gas, solid, you do not separate them. So this solid does not get separated. The secondary reactant is going to be this 2 sodium nitrate. Well, if we separated 2 sodium nitrate ion or compounds, we'd actually get 2 Na+s plus 2 NO3-. So you'll see here, each of these compounds were separated into their ionic forms. We had to write their ions. their charge on their ions. Anything that was other than AQ remains solid, and that's why this is called the total ionic. Everything that can be separated is separated. Great. Let's go to the last one. This is the net ionic. The net ionic takes into account only things that make up the precipitate. So what that means is we have to see which ions are floating around on the left-hand side of the equation of the total ionic and on the right-hand side of the equation, and then cancel them out. They're known as spectator ions. They don't take part in a reaction. So here we know that barium carbonate is the only solid that forms out of this reaction. So this, anything that makes up this, is going to be in the equation. So let's see how this works. Barium 2+ is found as barium 2+ over on the left, but it's not found as barium 2+ on the right. It's in a compound on the right. So we can write that down. This is not high enough. Net ionic. So we can write that down as part of our net ionic. Ba2+ aqueous. I wrote this down because it was in an ion form here, but it's in a compound form over here. They're not the same. Let's go to the next one. 2 nitrates are on the left, 2 nitrates are on the right. This is just like a normal equation. If they're found on the left and the right, they don't participate. They're called spectator ions, and we cross them out. We don't write them in this equation, the total ion, or the net ionic. 2 sodiums, 2 sodiums. Okay. 1 carbonate, no carbonates over here in their ionic forms. These are the only reactants we have. The only product we have left is barium carbonate. And there we go. So the molecular equation writes everything in their molecular formula, or in their molecular form. The total ionic writes everything that can be separated as their ions. And then the net ionic only writes out those things on the reactant side that make up the precipitate on the product side. We're going to do a lot of these equations in class tomorrow. But with that, this is a simple example. We're going to do a lot of these. Have a good night. I will see you all in class tomorrow.